Hi everyone. Today we're going to be talking about short circuiting in Python. So look at these two lines of code. The first line says result is equal to true or a print value. You might be thinking, wow, a print value. Just like I said in the last video, basically everything in Python, including variables and method calls, has this truthy or falsy value. And just know for the sake of this example that the print function, so this thing right here, evaluates to true. However, given the concept of short circuiting, which is that the program will not even bother to check the rest of the Boolean expression if it's already determined that the whole expression has to be true, this print statement will never run. And the reason that is because it sees the OR statement, and it knows that for an OR, only one of these things has to be true, and we've already seen the true statement. So it's saying that whatever is on the right side of the OR, it doesn't matter if it evaluates to true or false, this whole expression is already true because we've seen a true on the left side. So it basically saves computation, and it doesn't even bother checking the rest of the statement. This is what I mean by short circuiting. Another example of this is on line 3. So if we have false and some other thing, so something very similar happens where we have an AND statement, and we know that for AND statements to evaluate to true, both the left and the right side must be true. So now it's saying if we've already encountered a false and then we see an AND, it means that no matter what happens for the rest of the statement, it's not going to change the fact that this whole expression is going to evaluate to false. So sometimes we can actually use short circuiting to our benefit or intentionally implement short circuiting. And I'll give you an example right here. So first we have getNumber. So this is a function that's just going to return a number. In our case, it returns 0. Next, we're going to have another function called divideByNumber, and it's just going to divide 100 by the number that we pass in. And as you know, in math, dividing by 0 is something that gives an error. And so this program will crash if n equals 0. So basically, if we write some code like this, number is getNumber, and then we try to divide by 0, it's going to crash. And let's run it now. Yeah, we get a division by 0 error right here. So instead of writing it this dangerous way, we can actually use short circuiting to first check if the number is not equal to 0 before we try to divide by that number. So remember that numbers in Python have a truthy and falsy value, and the rule is as long as the number isn't 0, it has a truthy value. So first on line 15, we're going to get our number, and we're only going to divide by this number if the number is truthy. So basically, because logical expressions are read left to right, if number is 0, which in this case it is, it's never going to run this part of the code because it's going to say false and we know that ands need to be true on both sides in order for things to be, in order for the expression to be true overall. So this allows us to safely call divideByNumber.